Welcome students, in this class we will learn how to solve this given question. It's integral 0 to 1 ln of 2 positive x divided by 2 negative x times dx over x times root of 1 negative x squared. Now I will be applying the Leibniz technique to solve this. So foremost what I wish to do is I would like to take, let I be equal to this. Since I am applying the Leibniz technique, I would be utilizing a new variable and rewriting this function as I of p is equal to integral 0 to 1 ln, in place of 2 I'm going to say p, since p is the new variable. So this is rewritten as p positive x divided by p negative x times dx over x times root of 1 negative x squared. Now in this case the value of p is equal to 2. Okay, so that is a special case. So what I wish to do now is I would be differentiating both sides. We get, so we are differentiating with reference to p. So this is going to be d over dp times I suffix or I of p is equal to d over dp integral 0 to 1 ln of p positive x over p negative x times dx over x times root of 1 negative x squared. Now this is rewritten as I dash of p. I would move this total derivative into the integral. Since I already have a variable x, this is rewritten as dou over dou p of ln of p positive x divided by p negative x times, I'll write this as 1 over x times root of 1 negative x squared times dx. Now clearly this is a constant because the differentiation is with reference to partially the variable is p in question. So let me just show you the output when we partially differentiate ln of p positive x over p negative x. Now we have a logarithmic formula which is log of a over b is equal to ln a negative ln b. By this formula I can rewrite this as dou over dou p of ln of p positive x negative ln of p negative x. I differentiate this. This is going to be, in fact you can distribute this first, dou over dou p of ln of p positive x negative dou over dou p of ln of p negative x. So you partially differentiate, you get 1 over p positive x. Differentiation of p is 1. This is going to be 1 over p negative x. Differentiation of p is 1. I take the LCM as p positive x, p negative x. This is going to give me p negative x, negative of p positive x. I rewrite this, I get p negative x, negative p negative x over p squared negative x squared. Positive p negative p gets cancelled, giving me negative 2x over p squared negative x squared. This is the output when we partially differentiate ln of p positive x or divided by p negative x. So take this value and substitute it over here. So if I were to take this as say sum 2, I can rewrite 2. So therefore 2 is rewritten as I dash of p is equal to integral, of course the integration limit is 0 to 1 So this is 0 to 1, negative 2x over p squared negative x squared multiplied with 1 over x times root of 1 negative x squared times dx. Now this x and this x gets cancelled. You have negative 2, you can take that negative 2 out, and you have integral 0 to 1 over this quantity p squared negative x squared multiplied with root of 1 negative x squared times dx. So this is what we have got. Now what we need to do is we have to think of a proper substitution to handle this. So what I am going to do is I will try to utilize trigonometry in handling this. So let me take a new sheet of paper and let x be equal to, because the variable is x here, so what I will do is I will utilize x to be equal to, say, some sine t, and I differentiate this, I get dx is equal to cos t dt. When x is equal to 0, what happens here? If you substitute x is equal to 0, t will be equal to 0, and when x is equal to 1, t will be equal to pi over 2. So this is equal to negative 2, integral will be 0 to pi over 2, and in place of dx you substitute cos t dt divided by p squared negative sine squared t multiplied with root of 1 negative sine squared t. Now this is equal to negative 2 times 0 to pi over 2 cos t dt divided by p squared negative sine squared t, square root of sine squared t. 1 negative sine squared t is cos squared t, square root of cos squared t is cos t. Cos t gets cancelled, giving you negative 2 times integral 0 to pi over 2 dt over p squared negative sine squared t. Okay, so now what I wish to do is I would like to let us rewrite sine squared t with the identity cos squared t. So this is going to be equal to negative 2 integral 0 to pi over 2 dt divided by p squared negative of 1 negative cos squared t, which is equal to negative 2 times 0 to pi over 2 dt over p squared negative 1 positive cos squared t. So I'm going to rewrite this as a negative 2 integral 0 to pi over 2 dt over cos squared t positive p squared negative 1. Okay, so we have got up till here. Now what I wish to do next is I will multiply by secant squared t, and I would say multiply the numerator with secant squared t and the denominator with secant squared t. So this is equal to negative 2 times integral 0 to pi over 2 secant squared t times dt divided by cos squared t into secant squared t. Now secant t is 1 over cos t, right? So this is going to be multiplying by 1 over cos squared t. That's equivalent, right? Understanding. So cos squared t secant squared t gets cancelled. Probably maybe I will write one more step. Cos squared t multiplied with secant squared t positive p squared into secant squared t negative secant squared t. Now this gets cancelled, so you have negative 2 times integral 0 to pi over 2 you don't take anything out, just have it as it is. Secant square t multiplied with dt divided by, let me write this value. This is going to be p squared times secant square t negative secant square t. Okay, now what I wish to do is I wanted to make a representation. Now what will I do now? I have if I were to, okay, and there is a 1 here, so let me place that 1 there. Okay, so we will have to, okay, now let me just club these two together. So this is equal to negative 2 times integral 0 to pi over 2 secant square t dt divided by p squared negative 1 multiplied with the secant square t positive 1. Now what I wish to do now is I will take another side. Okay, so now I'm going to use this identity. Secant square t is equal to 1 positive tan square t. Okay, so I'm going to replace this with this. So that would be equal to negative 2 times integral 0 to pi over 2, you have a secant square t dt divided by p squared negative 1 multiplied with 1 positive tan square t, and you have that positive 1 there. You cannot forget that. Now what I wish to do is I would want to distribute p squared negative 1. So if I were to do that, 0 to pi over 2, let me take this off. What's that? Okay, 0 to pi over 2 secant square t dt divided by, this is p squared negative 1 positive p squared negative 1 multiplied with tan square t positive 1. Now negative 1 positive 1 gets cancelled, giving me negative 2 times integral 0 to pi over 2 secant square t dt divided by p squared, and you have p squared negative 1 times tan square t. I know you will be tempted to distribute tan square t, but don't do that. So let me go to another new side. So this is equal to negative 2 times integral 0 to pi over 2. Now what I wish to do is I would like to take this p squared negative 1 out. So this is secant square t dt divided by, so that tan square t is having a coefficient 1, so I take p squared negative 1 out. That would give me tan squared t positive p squared over p squared negative 1. So this is what I've got. Now I wish to make the following substitution. So let this tan t be equal to some u. Okay, now if I differentiate tan, I get secant square t dt is equal to du. Okay, so this is a constant, so we can take that out. It's going to be negative 2 divided by p squared negative 1 integral. I'm not fixing the limit as yet. So this is du divided by tan square t is u squared plus p squared divided by p squared negative 1. So this is similar to a squared. You remember we have done this formula, integral dx over x squared positive a squared is 1 over a tan inverse of x over a positive arbitrary constant c. Right? We know this formula. Now when t is equal to 0, u is equal to 0. When t is equal to pi over 2, you get infinity. Okay, that's simple. Now what I wish to do is I would like to apply this formula. So if I were to apply this formula, what happens? Negative 2 p squared negative 1 is there. This is tan and 1 over a. 1 over a is p divided by I have to write root of, because it's p squared negative 1, so that is written in this fashion. So tan inverse of x is u divided by a is p divided by root of p squared negative 1. I'm not going to fix in the arbitrary constant as yet, because we have the limits 0 to infinity, so we don't have to use any arbitrary constants. So now this is equal to negative 2 times root of p squared negative 1 divided by, now root p squared negative 1, can I write this as root of p squared negative 1 multiplied with p squared negative 1? Okay, that is there, and also we need a p there, this p. So this and this can be cancelled, and you have this quantity tan inverse of u. Now tan inverse of infinity, right, this entire thing will become infinity, so it's going to be tan inverse of infinity, which is pi over 2. You substitute 0, everything will become 0. So this is what you're getting. Okay, now we have to consider the left hand side, right? Now the left hand side, now let me write this quantity. This is nothing but pi over 2. I can place that pi over 2 there, right, pi over 2, and then in fact the 2 here and the 2 here can be cancelled, so no need to write pi over 2. I will just write pi. I got a pi there with a negative sign, and what else do I have? I have 1 over p times root of p squared negative 1. So this is what we have got. Now let me go to the left hand side. This is I dash. Now what do we take the function? We took I dash of p. So this is going to be I dash of p. Now to get rid of this, I need to integrate. So if I were to integrate both sides, let me write that down. Integrating both sides, we get, so what do we get? This is going to be I of p is equal to negative pi integral, and this is going to be dp over p times root of p squared negative 1. Okay, fine. Now we need to integrate this, right? So how are we going to integrate? Let me show you that. Let me go to a new page. Now we considered integral dp over p times root of p squared negative 1. Now let me take p to be equal to some secant theta. So dp is equal to, differentiation of secant theta is secant theta tan theta d theta. Substitute it here. This is going to be secant theta tan theta d theta divided by secant theta root of secant square theta negative 1. Now this is equal to secant gets cancelled, giving me integral tan theta d theta. Now root of secant theta negative 1. Now you have an identity, secant square theta negative tan square theta is equal to 1. So secant square theta negative 1 is equal to tan square theta. So you substitute that, you get root of tan square theta. So root of tan square theta will be tan theta. That tan theta and this tan theta gets cancelled, giving me integral d theta, which is nothing but theta. But we got p is equal to secant theta. So this means theta is secant inverse of p plus arbitrary. We have to substitute that in place of theta we substitute this secant inverse of p. So that's going to be secant inverse of p plus arbitrary constant c. So this is the working to show you that when you integrate this, you get negative pi times secant inverse of p plus arbitrary constant c, and this is equal to I of p. Now we have to find out the value of c, right? So how are we going to find out the value of c? Now I need to go back again to show you the original function. Okay, so we know that this is the original function, right? I of p. So let me write that. So we know that this is given. Actually I cannot say we know that, I have to say given that I of p is equal to integral 0 to 1 ln of p positive x over p negative x multiplied with 1 over x times the root of 1 negative x squared times dx. This is what is given. Now we have to find out the c. So what I'm going to do is I want to actually allow the limit to be tending to infinity. So what I will do is I will take p to tend to infinity. Now p is tending to infinity and we are much bothered, or we need to only be bothered about this quantity, right? Because this is the quantity which has got p. So this is going to be limit p tending to infinity of ln of p positive x divided by p negative x. Now what I would like to do here is, before applying limits, I would like to rewrite this as by taking p out. If I take p out, I will get p of 1 positive x over p. If I take p out here, I get p of 1 negative x over p. Okay, fair enough. Now p and p can be cancelled, giving you limit p tending to infinity with ln of 1 positive x over p divided by 1 negative x over p. Okay, now as p tends to infinity, 1 over p will tend to 0. So this will tend to 0, this will tend to 0, right? So you have ln of 1 over 1. Now what is ln 1? That's going to be 0. Okay, so what have you got? You got limit p tending to infinity of I of p is equal to 0. Now come back to this equation. Now let me take this as 3. Now what I'm going to do is I'm going to rewrite 3. Therefore 3 is, I'm going to rewrite this, I of p is equal to negative pi times secant inverse of p plus c, right? Now let me take limit p tending to infinity, right? So if I were to take limit p tending to infinity, this is going to be, you have to apply p tending to infinity for this entire thing. Okay, so this is constant, so this won't have any impact at all. So because we are only allowing p to be tending towards infinity, so this is going to be limit p tending to infinity. Now p is tending to infinity. What will happen? Secant inverse of infinity, that is going to give you pi over 2. You got a pi there with a negative sign, and you got the c will be as it is. On the left side, limit p tending to infinity, I of p is 0. So this is equal to 0. So therefore c is equal to, this can be moved to the other side. So it's going to be pi squared over 2. So this is the value for c. Again, I'm going to rewrite 3. Okay. Now using this information, 3 can be rewritten, right? So therefore 3 now becomes I of p is equal to negative pi times secant inverse of p plus pi square over 2. Okay, fair enough. But we need, what do we need? We need the value of p to be equal to 2, right? So therefore I of 2 is equal to negative pi times secant inverse of 2 plus pi square over 2. Now you need to find secant inverse of 2. Now let me show you how to find secant inverse of 2. Now let some theta be equal to secant inverse of 2. So that would mean I have secant theta is equal to 2. So this means 1 over cos theta is equal to 2. So therefore cos theta is equal to 1 over 2. So what is the value of theta for cos theta to be equal to 1 over 2? So cos theta should be, what is the value? Cos 30 is root 3 over 2. Cos 60 is 1 over 2. So theta is cos 60. How do you get cos 60? Pi divided by 3. Are you following? So the value of theta is pi over 3. So we have got that. So that would mean secant inverse of 2 is going to be pi over 3. Okay. Now take this value and substitute it here. So this is going to be I of 2 is equal to negative pi times pi over 3 plus pi squared over 2. This is going to be negative pi squared over 3 plus pi squared over 2. You take the LCM as 6. This is going to be negative 2 pi squared, positive 3 pi squared. That is going to give you pi squared over 6.